Hey folks, my name is Mickey. I am a product manager for the Oracle Container Engine for Kubernetes service, also known as OKE. And I am here today to talk to you about Kubernetes cluster management made easy. And so what does that really mean? Well, the idea is that we are trying to share some of the features of OKE that make it easy for enterprises to use Kubernetes without compromising on security, performance, flexibility, or reliability. And it wouldn't be an Oracle presentation without a safe harbor statement. So I'll put that on here since some of the stuff I'll be talking about today concerns the future direction of our service. So this is the agenda that we have. We're going to start off with just a level set, an overview of containers and of Kubernetes. And for those of you who are already experts, please don't worry. I won't go too deep into the weeds of information you already know. This is mainly just to bring other folks up to speed. After that, we'll do an overview of OKE. We'll explain, how OKE can help you out, also OKE and how that works with Kubernetes versions. Next up, we'll talk about the control plane and also the data plane and why we have to have different considerations for these different aspects of your Kubernetes cluster and keeping them secure and up to date. And then finally, we'll talk about some additional features that also simplify the process of running a Kubernetes cluster using the Oracle Container Engine. So again, as promised, here's our level set. So what are containers? Containers, simply put, are packages of software with dependencies and runtimes. Containers were huge when they facilitated the switch from monolithic applications to microservice ones. This came with a bunch of benefits like faster development cycles, quicker time to market, and also things like polyglot language support, which means the ability to write components of an application using different languages. But although there were a lot of benefits, new challenges arose as well. So for example, when we decouple the application from the host, we no longer have our hands on an organized platform. There's not one guy over in IT that you call to kick the server to get it running again. Also, when you decompose a large monolithic application into a bunch of discrete microservices, you're now going to have a much more complex environment to keep up to date and managed. For example, some of the issues that might arise are how do you address scale? How do you address the availability of your application? How do you network everything together? Also, what happens when a microservice stops working? How can you tell it stopped working and how do you get it up and running again? All these new challenges place a much larger burden on operations teams responsible for keeping your system healthy, which really means that they themselves need a system that can do all of these things for them, something to keep everything up and running, and also keep up with increasing demands on your service. And this is where container orchestrators like Kubernetes can help. So what is Kubernetes? Obviously, it's a buzzword. A lot of us have heard about it. It's a big talk in the marketplace. But fundamentally, it is an open source tool for automating the deployment, scaling, and also management of containerized applications. Basically, it's that platform that your operations team needs to benefit from microservices without dealing with all those drawbacks. More fundamentally, it's cluster software that has a control plane that manages and schedules work onto a data plane of worker nodes. While Kubernetes simplifies the challenges that I mentioned before, it also comes with its own learning curve. This learning curve, is something that can really be complex. It can be costly to your environment or to your teams managing the environment, and it can also be very time consuming as well. And this applies to both configuring the environment and building it from scratch, but then also maintaining it over time. And so here we are presented with yet another problem to address. And how do we address that problem? Well, that's where services like OKE come in. The Oracle Container Engine for Kubernetes, also known as OKE, is a fully managed, scalable, and highly available Kubernetes service. It's what our customers use to deploy containerized applications to Oracle Cloud Infrastructure. The service manages the cluster control plane fully on your behalf. There's no need to worry about the Kube API server, Kube Controller Manager, Cloud Controller Manager, etcd, and all those other components of your cluster. And you, the user, you share responsibility for managing the data plane where your containerized application workloads run. Kubernetes has a lot of moving parts. You just heard a little bit of word salad of me just naming a few that are part of the control plane. So the ability to simplify cluster creation and configuration, and also offload management opportunities or management responsibilities over time can actually remove a heavy burden from you and then place it onto the shoulders of your provider, which in this case is us. So I would say that keeping clusters running, patched, and up to date is probably the single most important job of a service provider. In the case of Kubernetes, that means ensuring that the latest versions of Kubernetes are supported and that they're supported as quickly as possible for users to benefit from new features and also from bug fixes. As some of you in the audience may know, the upstream Kubernetes project releases new versions 3 times a year, and OKE releases new Kubernetes versions within 90 days of their availability by upstream. New versions introduce new APIs, and they also deprecate and remove old ones. And so to give customers time to plan their upgrade schedules, we have a Kubernetes version release calendar that you can reference that includes dates for upcoming releases. Also, it's worth calling out that OKE doesn't force customers off of old versions when new ones are released, and provides customers with a path through unsupported versions to upgrade when they're ready for it. So there's no concern about being stranded if you're a little bit late to the upgrade game. Now, as I mentioned before, Kubernetes has a lot of moving parts, a lot of which can be chunked out into 2 different sections. One is the cluster control plane, and one is the data plane. And the Kubernetes versions and other updates need to be applied to both of these areas, each one of which is managed a little bit differently. So beginning with the control plane. As I mentioned before, the control plane is fully managed by OKE. That means you don't have to worry about the kubeAPI server and all those other cluster components that I mentioned previously. All of those are managed by Oracle. Also, because OKE distributes the Kubernetes control plane on multiple Oracle managed nodes, you have a highly available solution. So that means when it comes time to upgrade the control plane to change the Kubernetes version, you can do so with 0 downtime. To upgrade the control plane, you can see in the picture here, you specify a more recent Kubernetes version, and then you click upgrade, and that's it. Of course, it's going to be a little different when you're using other surfaces like Terraform or like the OCI API or command line. But in the console, it really is just as simple as one button. And actually, if you're making the API call, it could be just one click. After making that call, then you just sit back and wait a few minutes for the 0 downtime upgrade to complete. And following the upgrade's completion, you can now create new node pools or existing node pools with worker nodes running new versions. So that's really it for the control plane. The control plane, because it's fully managed, the experience is all taken care of for you. You don't have to worry about the hosts that the control plane itself is running on. Those are all managed by RSREs. You don't have to worry about performing the upgrade or worrying about that downtime. All of that is taken off of your plate and placed onto ours. Now, data plane upgrades are a little bit more complex because of the shared responsibility of the data plane. For example, worker nodes backed by compute instances, which are all of our worker nodes today, exist within our customers' tenancies. And for a lot of reasons related to privacy and just making sure that you're the only ones with access to your hosts, it's your responsibility to manage the underlying hosts and keep them up to date. Now, one thing that you may have heard about at CloudWorld are virtual nodes. These are managed by the OKE service. They live in one of Oracle's service tenancies. And it's not your responsibility to manage the underlying hosts. You are expected to just simply trigger a control plane update or an upgrade, excuse me, to these virtual nodes similar to the control plane. But that's not anything you have to really manage yourself. And so that's the direction that we're very excited about delivering to our customers moving forward. Now, to dive a little bit deeper into what data plane upgrades look like, I'm just going to talk about sort of the state of things today and then what's coming up soon. So even though worker nodes backed by compute instances are the responsibility for customers to manage and update, we have tools to make this process easier for our customers. Users today can update any node pool property. That includes Kubernetes version, it includes host image, the shape of the underlying compute instances, but also things like node metadata, or if you want to run a custom cloud init script when the host is provisioned, and more, like SSH keys or other properties. So the way that it works today is you update those properties, and those changes apply only to new nodes that are created within your node pool. And so what that means is that users, you, are responsible for actually propagating those changes or replacing all of those existing nodes with the old characteristics with ones that are new nodes running new characteristics. So how does this work today? There's a few different ways. One thing you can do is a fully out of place replacement where you spin up a second node pool and then you divert traffic from the original node pool running the old characteristics to the new one running the new characteristics. So that's one method. Another one that's a little bit less costly because you wouldn't have to have double the environment would be to do an in-place recreation, which when I say in place here, it's not the same nodes that are being upgraded because we prefer you to take the immutable approach of Kubernetes, which is cattle and not pets, not keeping these nodes alive forever. But in this case, we're talking about taking your node pool and updating the properties of that existing node pool, and then slowly replacing the nodes within that node pool with ones that are new and running those new characteristics. So we released a feature that we called our delete node API, which allows users to target specific nodes for termination so that you can terminate a node and have it recreated running the updated characteristics. Along with this feature, we also added some tunable grace periods that allow you to ensure workloads can safely be rescheduled onto other nodes prior to the termination of that node. Another part of this feature that I think is pretty cool is that users can choose whether they want to preserve nodes that fail to evict workloads by the end of that grace period, or if they would prefer that node to be forcibly terminated. And the reason for this is that we had some big users come to us and say, hey, we accidentally delete work nodes sometimes. There are times where we'll run a Terraform script and it doesn't work the way that we expect, and then we delete something that's mission critical that violates a pod disruption budget. And so in order to make sure that something like that doesn't happen, we've added these new levers that will prevent the termination from occurring if it can't all be finished, if the eviction can't be completed by the end of the grace period. And finally, one other cool lever that's part of this feature is the ability to specify whether you want to replace terminated nodes with updated nodes, which would be the case if you're trying to use this feature for a node pool upgrade, or if you prefer to just atomically scale the node pool down by however many nodes you've terminated after the termination is complete. So that is a lot about how our data plane process works today. That's how our data plane upgrades work today. But what we wanted to do is that, acknowledging that a lot of our users are going to continue to use this sort of managed node construct backed by compute instances, we wanted to simplify the upgrade process that I just mentioned. It may be easy for me to come up here and say, all you need to do is terminate a single node at a time and then have it recreated in your environment, or switch from one node pool to another. But when it comes down to brass tacks, and maybe if you have a node pool that has tens or hundreds or even 1,000 nodes in it, that can be a lot more cumbersome than it sounds like. We have a lot of users that have taken that and then sort of wrapped their own orchestration around it. And while that's a fit for users who are very technically savvy and know what they're doing, at the end of the day, that's not going to be the best fit for all of our users. So what we wanted to do is introduce a feature to take this toil away, to take the responsibility of customers having to perform their own upgrades. And we wanted to automate it. We wanted to take the node pool cycling process and make it so that just like you can upgrade your control plane with one click, you can also do the same for your data plane. And when I say upgrade, it really should be upgrade and update like I have on the slide here, because this applies to any of those properties that I previously mentioned. You could be upgrading in that you're changing your host image to a newer version of Oracle Linux, but it could also be an upgrade in that you're changing the Kubernetes version. And if you're not upgrading, it could be that you're updating an SSH key or updating a cloud init script that runs in your nodes. So the cool thing about this is that we're not just adding this automation around node pool cycling for specific version-related parameters of your node pool, but we're adding it for all existing node pool properties. And so again, the goal here is to just simplify infrastructure operation. We want to make it as easy as possible for you to control the updates to your compute nodes underlying your cluster. For users who prefer the more granular control, the current manual update option will still exist for them. That's not going away. But for all other users, this will make it much easier to update node pools. Also, when we launch this, we're going to launch it with some additional control or additional levers. For example, max surge. So max surge is the ability to specify the number of nodes that you are comfortable having your node pool surge up to for the duration of this cycling process. Now, why would you want to surge up? Well, you might want to surge up if you want to limit downtime to your application. Of course, if you're propagating this change to all nodes in a node pool, nodes are going to have to be unavailable for some given period of time. And if you want to make sure that the number of nodes that are available at a given time does not dip below your expectations, you can surge up to a higher value. So that would be what you want to do to limit downtime. Alternatively, for customers who are more cost conscious, the way that they would deal with the loss of availability of nodes that are being upgraded would be using a max unavailable number. So that would be great for customers who want to limit costs. That would basically say if you wanted to have a node pool that had 10 nodes and you wanted to make sure that at least 7 of those nodes were online at one time, you'd set your max unavailable to 3, and then you could upgrade all 3 of those nodes in parallel. And so the idea, again, of providing these levers is just providing customers with the ability to choose whether they want to limit downtime or limit costs. And in doing so, just decide how many nodes they want upgraded at a given time. So again, the reason we're very excited about this is because we are looking to do everything we can as a managed service provider to limit the toil experienced by our customers and get them to focus on the things that we think are the most important, like managing business logic that exists within containers in their environment. So one step beyond our managed node upgrades are virtual nodes. And virtual nodes, you won't have to wait long at all to use because they're actually coming out when you hear this presentation. So virtual nodes are one step beyond managed node pools. You can think of them as Kubernetes without infrastructure operation. Oracle is responsible not only for managing the control plane, but for managing all data plane resources. You only need to be concerned with managing your containerized applications via the Kubernetes API. Virtual nodes are awesome because they deal with a lot of those challenges that we talked about before. They provide elastic capacity without requiring you to configure cluster autoscaler, which is a commonly used open source Kubernetes project that allows you to add nodes to node pools in your cluster. And so this addresses the need for customers to ensure that their application is always able to service the workload the amount of work being presented to it, the number of customers that are trying to access it simultaneously. You can still use common Kubernetes tools like the horizontal pod autoscaler and vertical pod autoscaler to change the number of pods you have running or the size of pods you have running. And that would be the way that you scale Kubernetes at the deployment level. But you wouldn't have to do so at the underlying infrastructure level because, again, that's all handled for you. When it comes to patching and upgrades, whether that's OS patching or Kubernetes versions, all of those are performed by OKE. There's no OS patching at all because these instances exist within the OKE service tenancy. And when it comes to Kubernetes versions, just like for the control plane, those are going to be user triggered. Now, segueing a little bit away from just the patching and Kubernetes version management, there are other benefits to using virtual nodes as well. These benefits include things like cost optimization. You're no longer going to have to provision full nodes that you're only using a portion of the capacity of. Instead, you are only going to pay for the resources that are used by Kubernetes pods in your cluster. So, when you choose those resource limits and reservations for your pods, that is what you're going to be paying for, and that's what will be provisioned on the back end. Also, there's going to be strong security and isolation at the pod level. There's great multi-tenancy with the cluster because now pods are isolated at the kernel level because each one of those pods is running in its own container instance instead of having them shared across a worker node host. And all of this is to say is that we now have a great new option for users who don't want or need control over the underlying hosts. Of course, there are always going to be users that want to have managed nodes. Maybe they want to have more control over the shape, or they want to do something special to the underlying host, bring their own antivirus software, or they just need to have something where they have SSH level access. But for users who really just want to focus on the Kubernetes API and the containers running in their environment, this is the solution for that. Now, for the last portion of this talk, I wanted to shift gears away from Kubernetes version and host patch and related management, and instead talk about some of the other features that make it easier for customers to configure clusters using OKE, configure and manage. So again, the purpose of this talk was to talk about how OKE simplifies configuring secure and reliable clusters. And so I wanted to highlight some of the features that we have that enable users to do just that. So to begin with, users can provision fully private clusters with access to the Kubernetes API and node pools restricted using their VCN. So what that means is that, unlike other providers who might have the Kubernetes API endpoint restricted using role-based access control, but still actually accessible to the public internet, instead, what we've done is we put that Kubernetes API endpoint in a virtual cloud network that you control, and you can control access to that API endpoint by whatever means you prefer. Similarly, you can put node pools in a subnet that also is controlled by your VCN, and very granularly limit access to nodes within that node pool. And then, of course, you can always just expose them using something like an ingress controller. We offer network security at multiple levels. There are network security groups that allow users to define granular network security rules for node pools and also for load balancers in the cluster. There's VCN native pod networking, which is our own container networking interface, or CNI, that allows users to directly connect Kubernetes pods using an OCI VCN. For example, if you chose, you could give each pod its own IP address and then configure routing that way. And also things like network policy are supported if you wanted to bring your own network policy to control traffic, and security lists, and just a host of other things that allow you to have very deep control over your cluster from a networking perspective. When it comes to data, data is encrypted at rest and in transit by default. And if you choose, you can go one step forward by bringing your own encryption keys. So that's something that we support as well. Also, for folks that are very conscious of what gets deployed to their environment, which I suppose everyone should be, you can set up image signing, scanning, and verification. So image scanning is kind of the first step. So it's the ability for you to take all of the container images that you'll be deploying to your cluster and scan them for noted CVEs or vulnerabilities. Then, after ensuring those images are free of vulnerabilities, or at least they're limited, you can sign the image, which sort of signs off on or attests to the quality or security of the image. For example, you could have some sort of security persona within your environment who does this. And then finally, you can configure deploy time verification that prevents unsigned images from being deployed to a cluster. And so all of those together give you a lot more control over what ends up deployed to your Kubernetes environment. I think it's also worth calling out that OKE complies with countless compliance standards, and also hardens clusters following CIS benchmarks and STIG guidelines for cluster hardening. We have lots of folks who use our services from the government, varieties of governments, and also from healthcare and finance use cases. And so all of them have very strict compliance requirements. And the good thing is that OKE complies with all of them. And so you can trust us with all sorts of workloads. Now, one other thing that I think it's worth calling out is that users can go one step further to securing their applications using a zero trust model by making use of the OCI service mesh. So service meshes provide security, observability, also network traffic management for cloud native applications. And they do so without requiring any changes to the applications. What'll happen is you'll install the OCI service mesh, which is a fully managed mesh. You don't have to worry about a bunch of CRDs, keeping them up to date in your cluster. And what you would do is you basically just put a sidecar proxy with all of the containers that run in your environment. And that proxy is used to do things like manage the traffic. And then because those proxies are sitting there, they're also great for security and observability as well. And again, all of those are used without the need to use some additional libraries for security or for observability or for any of these other common use cases that you might need to support for delivering an enterprise-grade application. So all this is to say that the OCI service mesh simplifies the development and operation of microservices at scale. And the last thing I wanted to talk about related to OKE, and this just has to do with more tied to management, is that, again, instead of having to create a Kubernetes cluster from scratch and create worker node instances by installing the kubelet and ensuring that the networking is all set up so that it can talk to your control plane correctly. Instead, all of that is done for you, and it's not just basic compute shapes that are supported, but basically every single compute shape that you see available from OCI is supported within OKE, with a handful of exceptions that we are working to support as we speak. One that I think is very cool are the use of compute flex shapes. And so flex shapes are shapes that give you more control over the specific number of OCPUs or computing power, and then also the required amount of memory or RAM for your worker nodes. So depending on your use case, you can right size those nodes to fix that use case or to match that use case. Similarly, we don't just have compute flex shape support, but we also have load balancer flex support as well. And so what that means is, instead of over provisioning a load balancer to front your application, that has some sort of large number of megabits per second that it supports, but you only really need that a few times a day. Instead, you can actually set a new type of load balancer up, a flexible load balancer that will dynamically change the supported amount of connections based on the traffic that you receive. And again, this is very helpful for right-sizing workloads, so you're not paying for more than you actually are using. Aside from the flex shapes and the ability to right-size environments, we also support a number of different architectures. There's x86, there's also GPUs and ARM. All of those can be used for worker nodes in a Kubernetes cluster within OKE today. Also, I think it's worth calling out, you can use bare metal shapes. That was one of the big value props of OCI when it first launched, and that's still something that we have plenty of customers using on a regular basis. Also, one thing that we supported within the last year are greatly improved worker node startup times. So these are our new optimized images that are for use as OKE worker nodes specifically. And what they do is, when compared to the more generic OCI platform images, they double the rate at which worker nodes spin up. And by that, I mean half the rate. So instead of having a worker node spin up in X amount of time, it would spin up in 1/2 of X. And the last thing that I think is worth calling out when it comes to managing clusters is, as I mentioned before, there are always going to be some folks who prefer to have managed compute instances as opposed to ones that are fully controlled by Oracle. And for those folks, we have a very, very great level of control by means of worker node startup scripts. So if you need to do something like customize the underlying compute image using your own Yum repo, or if you wanted to bring your own security tools, or if you just wanted to do something unique, you can actually add your own logic to the worker node startup scripts. This could work or run before or after the OKE logic runs to do things like configure an internal Yum repo or set up a corporate proxy. You could use kubelet extra args to configure taints to control which nodes pods are scheduled onto. You could also do something like configure security enhanced Linux for compliance purposes. So all of this is to say that not only can you have the ability to offload management responsibility using OKE, using things like virtual nodes, but also if you have the opposite case, if you want to have more control, you have that option as well. And so that about wraps it up for me today. I wanted to say thank you to everybody who took the time to listen to this presentation. We are always excited to talk to an audience of our users or future users. And thank you very much.